Hello, everyone. Good afternoon. Hope everyone is doing well. Okay, so today we will move on to another topic or to another part of our unit, which is on pedestrian transport. Okay, so we are done with transport planning. We are done with intersection analysis. So now we move on to one subheading, which is pedestrian transport, before next week, before we move into rail system. All right. So this topic is very short topic, and it's an independent topic on its own, but we felt that it's important to include this because, because we need to think of all our road users, including the vulnerable ones like pedestrian. Okay. So then we look at this. So at the end of this lesson, what I hope that you will be able to get is that you can describe the pedestrian crossing facilities, and you can design pedestrian walkways in relation to this DDA requirement. Okay. So we are DDA requirement, Disability Discrimination Act. The requirement has a lot, it covers a lot of things. What we are looking at is just related to civil engineering design works. Okay, so there are two parts to this week's lesson. One is on pedestrian crossing facilities. We'll discuss all this, and then we'll move into the design before we finally look into what's that? Tactile indicator. Okay, so pedestrian control, we based it on Australian Standard 1742, Part 10, which is on pedestrian control and protection. So this is under the Manual of Uniform Traffic Control Devices. Okay, so we can look further into this. All right, so general requirement for us to have pedestrian facilities. And when we say facilities here, we are referring to all sorts of different pedestrian crossings or helping the pedestrians to cross safely, okay, such as your zebra crossing, traffic lights, all these are different facilities. All right, so pedestrian facilities must be established based on realistic demand. So you don't simply put a pedestrian facility unless there is some sort of demand. If it is just to cater for one, you may rethink about that and see if there are any alternative to that. Yeah. Facilities that are not used will soon be ignored and becomes an obstruction in the roadway. Yeah? So this is what we don't want. So that we must provide based on demand. Okay. Design for pedestrians includes all footpath users, which will include all these different categories: wheelchair users, motorized or manual, either it's motorized or manual, mobility scooter users, children 12 years old or younger, whether they are on a bike or walking, and accompanying adults, people with prams and shopping trolleys, and people with disabilities. Okay, so these are all the category of users of your footpath. All right, and this footpath could be in a very busy in a very busy central district area in the middle of the town, or it could be a footpath in the neighborhood. The footpath could be at different locations. Okay, so therefore it caters for different category of users. Right, so then we look at the different pedestrian facilities that are available, and we categorize these facilities into time-separated facilities, physical pedestrian facilities, and grade separation, as well as warning signs. Okay, but mainly we concentrate on the first three. All right. So time-separated facilities means the objective is to minimize conflict between pedestrian and vehicles by allotting short time periods. Okay, so meaning to say pedestrian, you get some time. After that, vehicles, you get some time to move. For use of section of road by pedestrians, alternating with periods for use by vehicles. Okay, so it means that pedestrian, sometimes you get the time to cross safely without interruption, and then vehicle, you get to move without interruption for a certain period of time. Okay, so examples of treatments or example of the facilities are pedestrian crossings, such as zebra crossing. All right, so you cannot have both pedestrian and vehicles go at the same time. That will be accident. Okay, so children's crossing, same thing. You need to give pedestrian or children in this case to cross first, and then the cars will cross, and then alternate it with children crossing again. Okay, pedestrian actuated traffic signals at mid-block. Mid-block meaning to say between two intersections. So if you have pedestrian actuated, they press onto the traffic signals, then they get green time, vehicle will get red time. Okay, so then you also alternate the time to the pedestrian and vehicles. And modification from these traffic signals would be pelican crossings and pedestrian at signalized intersection. Okay, so we'll see more of this treatment in the next few slides. The second category, we have physical pedestrian facilities, and the objective of this is to increase the safety of pedestrians by use of physical aid within the roadway. Okay, so stressing on physical aid within the roadway so as to reduce conflict between vehicles and pedestrian. Yeah? Reduce conflicts only. So it doesn't eliminate the conflict totally. There is still a potential for crash, but we try to reduce it. And the objective of these facilities is to reduce that conflict. Okay, and simplify the decisions which both pedestrians and drivers have to make. All right, so this is not giving time, but rather to help your pedestrians cross safely by reducing conflict between pedestrian and vehicles. So what are the examples of treatments? Pedestrian refuges, okay, your traffic islands. Pedestrians can stand on the traffic island, so this is out of the way of your vehicle. Okay, crash may still happen, but then they are on a ground that vehicle don't normally cross into. Okay, medians, curb extensions, or loading islands. So if you look at this, most of these are raised islands and medians, and this kind of areas will shelter the pedestrians from the vehicles. Safety zones, pedestrian fencing. Okay, then we have grade separation, and the objective is to increase the safety of pedestrians by eliminating conflict between vehicles and pedestrians. And for grade separation, you have subway and bridges, overhead bridges. Okay, so this will definitely eliminate the conflict between vehicles and pedestrians. Because when you have subways, your vehicle is on top, the pedestrian will cross beneath the roadway. So you go your way, pedestrian, I go my way. Okay, so it eliminates the conflict totally, unless, of course, the pedestrians do not use the facility. Warning signs is to warn the presence of pedestrians or pedestrian facilities ahead. Okay, so this is basically just warning sign. All right, so like I said, we are concentrated on the first three. And so let's move on to look at the different facilities that we have. So first one, time separated facilities. Yeah? So this one, remember, time, we give time to pedestrians, then we give time to vehicles to cross. So first up will be zebra crossing. We have one on campus. Okay. If you are still not sure, or if you have not been to campus yet, there is one on campus, zebra crossing. a part of the roadway marked by white stripes parallel to the center of the line of the roadway. Only used where traffic speeds are low. You cannot use this if you have very high traffic speeds. Low traffic speeds like in campus, yes, you can use it. By the way, if you have pedestrian crossing, vehicle has to stop for the pedestrians to cross. I hope you do that. Do you do that? Do you stop to give way to the pedestrians to cross? Yeah, I really hope you do, okay? At least start practicing that in campus. All right, now we see that low speed, how low? Average speed less than 50 kilometer per hour, then we can make use of pedestrian crossing. Zebra crossing. And for zebra crossing, this is not regulated by traffic signals. Some zebra crossings are located at traffic signals, say signalized intersection. Those are not zebra crossing anymore. Okay, those are pedestrian crossing at signalized intersection. All right, so this one is just purely zebra crossing. No traffic light, no traffic signals to regulate the movement. Yeah, so it's purely based on the drivers respecting these facilities and slowing down if they see a pedestrian crossing the road. Or maybe a zebra crossing the road. Okay, so the requirement and options for installation of a zebra crossing, it can be at mid-block crossing, where no more than one lane of moving traffic in any direction, adequate sight distance for vehicles and pedestrians, and vehicle speed less than 50 kilometer per hour, and 85th percentile less than 60. Okay, definitely not for arterial roads. It could be for local street, collector still okay, or sub-collector still okay. Check the speed at that area, in that area. Zebra crossing can also be used for crossing on slip lanes, and many of you have designed slip lanes for your assignment 1. Yeah, so zebra crossing could be used as well for slip lanes. Okay, but again, no more than one lane of moving traffic in any direction. So you can only provide zebra crossing if the vehicle is if you are crossing across one lane in any direction, just one direction. Okay. Or other locations that you can provide may be provided at other locations by the following above requirements, with safety of all road users properly addressed. Okay, so what if these requirements are not met? If the conditions are not met, then pedestrian actuated traffic signals will have to be installed. You say, for example, speed 60 or more, 70, then you have to install traffic signals. If you have 4-lane two-way, then you have to install traffic signals. If you have more than one lane in 2 different directions, then you may look at installing traffic signals. Okay, so if these conditions are not met, then we use traffic signals. All right, and likewise, if crossing on slip, if not met as well, we use signalized slip lane crossing. So suitable for shopping streets, commercial areas where drivers are alert and they are moving slow. They are not at high speed. Okay, not appropriate for multi-lane arterial roads carrying substantial traffic volumes. Must include adequate lighting at night, and guidelines require twin flashing, yellow lights facing each direction. Okay, so this is this is in Australia. They have this symbol to indicate pedestrian crossing. So how they install this? You see this sign, and the flashing light is here at the side. This is not to regulate. This flashing light does not quite regulate the movement. Okay, the vehicle will still have to slow down and give way if there are pedestrians crossing. Okay, and this longitudinal bars here, 3 meter long, that's minimum. Now, if there are a lot of pedestrians, we could extend it beyond the 3 meters. Now, a modification, second treatment, a modification of zebra crossing is what we call as wombat crossing. Okay? And this one is a raised crossing, raised pedestrian crossing. So if you look at this figure, this photo, this part where the crossing for the pedestrian, this is higher than here. Okay, so this is a ramp going up to this. So the idea is that the pedestrian, they will have a level walkway, and for the driver, because this is raised, driver will have to slow down. All right, so we are forcing the drivers to slow down. With zebra crossing, it's flat on the road, same level as the road. Vehicles, drivers may not notice the pedestrians and may just drive forward. Okay, if you are in Kuching, one example that I can give to you, a very good example would be the Kuching Airport. If you go to Kuching Airport, the outer lane, on the outer lane side, on the arrival, on the arrival, the lower ground, you have that raised crossing. If I have time, I'll get a photo of that. Okay, then you have children's crossing. Yep. So then this is usually, for children's crossing, it is usually manned by a traffic warden to guide the children to cross safely. Okay. So the idea is the same, but children crossing is provided near near a school usually, so that the school going, the students can cross safely. Okay, so school crossing supervisor or traffic warden, often employed to supervise the crossing before and after school. Used generally on local streets and in speed zones of 60 or less, and must have 2 parallel crosswalk lines across the road. So if we look at this, there are 2 lines here across the road. Okay, so 2 parallel lines, and you must have 2 red and white posts on each side of the road. So this is red and white post, another 2 here, and stop lines 6 meters back from the crosswalk lines. So this is the stop line, and this distance is 6 meters. Okay, so this is the stop line, and you have 6 meters away from the cross line. Right, only legally children's crossing when the children crossing flags are displayed. And if you look at this, there's a children crossing flag here. So yeah, this again is an illustration of what is shown to you just now. Okay, so the next facility, we have pedestrian actuated traffic signals at mid-block, and installation of signals at which changes of signal aspect are initiated by pedestrian, usually by pressing a button. Okay, so they have buttons here. They have buttons here. If there is a pedestrian, they push this button, then it will inform the system that there is a pedestrian waiting to cross, and for drivers, it will turn red, and for pedestrians, it will turn green. Okay. So this is installed for locations where significant numbers of pedestrians cross, where pedestrian crash history is significant and appropriate for arterial roads. Okay. and it provides positive instruction to pedestrians whether to walk or don't walk. All right, so if zebra crossing cannot be fulfilled, the requirements for zebra crossing cannot be fulfilled, then we need to provide for pedestrian actuated traffic signals. Okay, so installation guidelines are given here. Limit of zebra crossing are exceeded, whether it's in terms of speed or in terms of the number of lanes. And crossing is within a coordinated traffic signal system or within a traffic light or close to a railway crossing with active control. Okay, and if it is in an area where it caters for significant numbers of people with disabilities, we may also consider installing pedestrian actuated traffic signals. Even if, let's say, zebra crossing requirements are fulfilled, but because the area has a significant number of people with disabilities, then we may actually install this, okay, pedestrian traffic signals. All right, so it is not suited for areas where speed limit is greater than 80 or very, very close to other traffic signals. Yeah. We are talking about mid-block, so it has to be in between two intersections. But if the two intersections are signalized intersection and they are very close by, very close to each other, then we don't put a mid-block crossing anymore. It creates confusion and people can actually go to the intersection and cross there. Okay, so design features, whether it's two parallel, I think I'll use this. Okay, the design feature, single carriageway, and if you have a dual carriageway. So let's look at single carriageway. This single carriageway, 4-lane two-way, so it's going in this direction and these two lanes are coming in this direction. So what we do is we have a stop line here for pedestrians and a traffic signal. And this is the crossing part for pedestrians. Okay, so 6 meters away from the pedestrian crossing. And this width, pedestrian crossing width is about 2.4 meters. And this is for pedestrian. There's a push button here for pedestrians to activate the traffic signals. Okay. And if you have a dual carriageway, and this diagram only shows one side of the carriageway. All right. So if you look at this, this is 2-lane going in this direction, and this part is the median, 2.4 to 3.5 meter. And then on the other side of the carriageway, you have the other direction. All right. So for this kind of carriageway, dual carriageway, we usually do a stagger crossing. That means the pedestrian will have to cross the entire road twice. Once to cross this half of the carriageway, and then they wait here, and then later on to cross the second half of the carriageway. Okay. Yeah, so again, some other things are quite similar. You have the push button, the stop line, and when we have stagger, we usually would separate it slightly, the stagger distance here. So crossing for this side is here, and crossing for this carriageway is here. Okay, so this, you have a bit of stagger here, is to discourage children from just going through the whole road. Right. So pedestrian signal, in terms of the signal display, we have green man display. For pedestrian, usually you have green man, green walking man sometimes. At seconds generally for undivided roads, but over 8 meters wide. Flashing red man for clearance. They don't have yellow light, so they have flashing red man, and then after flashing, then it becomes a solid red, a continuous red man. Okay. So when we design for pedestrian signals, we are always assuming a standard walking speed, which is about 1.2 meter per second. And this pedestrian signal is not responsive to different pedestrian abilities. All right. So if you have areas with people who are disabled, then if you know that that area has high number of people with disabilities, then we may look at adjusting the walk time, the green time, by adding some additional seconds in. Otherwise, if we are talking about standard crossing time, then this is usually what we do. Okay, so for divided road, walk time to cross to just past the median. Yeah, so meaning to say, for divided, you walk just slightly until here, just past the median. Okay, so walking time is crossing time, crossing distance, we multiply by 1.2 meter per second, and then we add on another 2 seconds. All right, so if you know that that area has a lot of people who either has disabilities or maybe even say senior citizens who can't walk very fast, then we may look at increasing this 2 seconds safety buffer. Okay, so clearance time to walk to cross wider roadway is about 1.5 meter per second. So we design the signal display time or pedestrian time using this graph, and we'll go through this graph in tutorial to see how we get the time for pedestrians. Okay, so next up we have Pelican Crossing. And Pelican Crossing is actually a modification of the pedestrian actuated traffic signals because it incorporates the flashing yellow display. If we look at this, for pedestrians, if it is a normal pedestrian, it is very time wasting because the vehicle will have to wait until they turn green, even if the pedestrian has finished crossing and the traffic light has not turned green for the vehicle, they cannot move. So when we introduce a flashing yellow, it introduces an early start opportunity for the vehicles. So meaning to say, if they see no pedestrians, they can proceed if the pedestrians have cleared the crossing. Okay, so it gives a bit of authority to the drivers to actually judge if pedestrians have finished crossing, then they can start their vehicles without having to wait until green time. So this in turn reduces the traffic delays, right? And if we look at this measure of delays here between pedestrian operated signals and also Pelican Crossing, you can see that for queue length, there's a reduction of about 33%, and delay, especially to the first vehicle, that's about 42%, and total vehicle delay is about 52%. So that's a lot of reduction. Okay, so next up we have Puffin Crossing. And for Puffin Crossing, this again is another modification of the pedestrian actuated signals. And it is equipped with this infrared or microwave detector. So this is to detect, this is a bit smart, it can detect pedestrians on the roadway. Okay, so if they see it through the detection, if they see that pedestrian requires longer time, they have not fully cleared the intersection or fully cleared the crossing, then it will give longer time for the pedestrians to continue crossing. Okay. Or if pedestrians have already cleared, everybody runs across, maybe, then shorter time, and it will turn red and green for the vehicles. So this is a bit more responsive. And again, if we look at what's that? Oh, this should be Puffin Crossing. Sorry. Yeah. So if we look at the statistics, the puffing crossing total delay reduction is about 40%. Not as big as the other one, Pelican Crossing, but well, 40% is still quite a lot. Right. So another one, the last one, I think, pedestrian crosswalks at signalized intersection. Okay, so this is at the signalized intersection. Yeah. This has intersection. All right. So you have pedestrian crossing here, and this is staggered, cross to halfway to the median and cross the second time. Okay. In general, should provide a crosswalk across each leg of a signalized cross intersection and across at least 2 legs of a T intersection. So this is a very famous crossing in Tokyo, Shibuya crossing. And you look at this crossing, it has many, many different directions. This is a crossroad. So this is crossing across the road. This is also crossing across the road. And look at all the people. And this is crossing diagonally. So they save time. You don't, if you're coming from here and you want to go to this side, you don't need to cross 2 times. You just make diagonal crossing. And from your traffic signals previously, I think I read that this week, you would have learned that pedestrians may have their own phase to cross. And for this crossing, definitely the pedestrians have their own phase. Vehicle will have few phases, but pedestrians will definitely have a phase. And just for your information, if you are interested to know, if you are familiar with the story of a very loyal dog, Hachiko, the statue of Hachiko is, I believe it's somewhere here. Yeah, I think it's here. Yep. So it's just situated there. Okay. So this is not really a facility, but this is to help in terms of the crossing, is countdown timers. We do see that quite a lot in Kuching. You have countdown timers, especially for vehicles. Okay, so you have countdown timers. It will tell you the remaining time. All right, so moving on to the next second facility, which is physical pedestrian facilities. And remember, this second one, we don't have time, but it is to help in crossing, simplify your decision making. Okay, so first off is the pedestrian refuge. This is pedestrian refuge. So this is just painted section. Okay, this is channelization, painted, not raised, but it simply allows your pedestrian to shelter here, therefore minimizing conflict. Okay, and it allows your pedestrian to actually cross the road in 2 stages. They cross one side, then they cross another. All right, so this one is raised, so they cross one side and then they cross another side. Okay, so again, yeah, so this one is pedestrian refuge as well. All right, and it provides physical protection. If they stand on here, chances for vehicles to knock into them is very much lessened. Okay, so may encourage reduced vehicle speeds and available to pedestrian at all time because the facility is just there. So yeah, this one, yeah, so this one is another refuge island. Okay. And for roundabout, this roundabout, if you look at this, for Australia, the roundabout sizes are usually typically like this, not very big ones. So then they allow pedestrians to cross, and the splitter island serves as a shelter area for pedestrians and for them to cross twice, 2-stage crossing. So one stage and the second stage. Right? But not often seen as not pedestrian friendly. Crash history of pedestrians at roundabouts is generally better than at traffic signals, simply because the vehicles are moving at a slower speed. Yep. Roundabout, some of them, they have this is one splitter island, but they open up the splitter island, so it helps for pedestrians to cross easier. Because if, let's say, your pedestrians, they may be on the wheelchair, or they may have some trolleys with them, then this kind of crossing will help them to cross easier. Okay. So another facility is extended curbs. And from the diagram, if you look at this, the curbs are here and on this side. So what we do is to extend it. These are parking spaces. We take out some of the parking spaces and we extend the curb so that your pedestrian will stand here and be seen clearly by the motorist. So it's easier for the motorist to see. And with that, the motorists, hopefully, they will stop and allow the pedestrians to cross. Okay, so this facility is used together with zebra crossing. So this is extended curb, but this one has a signalized. But the idea is that it is similar, so that pedestrian has shorter distance to cross and visibility for drivers. Okay, then we have also pedestrian fencing, and this is to keep the pedestrians to the preferred path. We don't want them to go into different areas, so we fence it up so that they only are allowed to walk within that area. Okay, avoid solid horizontal rails near pedestrian crossings to guide pedestrians to the crossing. Sometimes outside hotels to keep patrons off the roadway. At bus stops to keep pedestrians off the roadway as well. Okay, so the last facilities, the last type of facility is grade separation. And we only have two types for this, whether it's overpass or overhead bridges or subways. Okay, so the idea of this is to eliminate any conflict point at all. And it provides the highest level of safety because there is separation of your pedestrian and vehicles. Okay, so each of these are happy to go on their own way. And when it is separated like this, vehicles will have uninterrupted movements. But the issue is that we often see this, pedestrians not using the facility, or pedestrian will just cross however they like. Okay, because of additional walking time, and sometimes it's also because you have to climb up the stairs. That has been mitigated by putting escalators, so that is automated. But if the escalator is not working, then we see pedestrians will not climb up the escalator as well. So these are the issues associated with overhead bridges. Okay. And then we have subways, right? Subways, the idea is the same, equal high level of safety because of the separation. But the issue with subways is that due to personal safety concerns, activities within the underpasses are often hidden from public. You can't really see what is happening. For vehicles, they can't see what is happening here. So this is sort of hidden. And therefore, personal safety concern is an issue. With overhead bridges, if we make it as without the banners, then we would still be able to see what is happening with overhead bridges. All right, so those are the facilities. Any question up to this point? Right, I don't see any question, so I will continue on. Okay, providing for people with a disability. Okay, so this part of the topic discusses on providing for people with disability, because in 1992, this Disability Discrimination Act was approved in Australia. And basically what the act is all about is that we cater for people with disability. We don't discriminate them, okay? Just because they have disabilities doesn't mean that they cannot have the same right to society, all right, or to facilities. So then we design for mobility impaired and vision impaired person. Okay, so mobility impaired means they have difficulty moving around. Maybe people with on a wheelchair, or people who have walking difficulties, right? And visually impaired persons, they have difficulty to see. Okay? Not necessarily blind, but sometimes they could have difficulty. They don't see very clear vision. Yeah, so all these categories are included. Yeah? So then when we design for these two categories of users, we have to put in audio tactile push buttons. For vision impaired persons, you put a push button, they do not know when the traffic light is green. Just imagine if you close your eyes, you push the button, you wait for it to turn green, but when is it turning green? You don't know. So then we need to have audio tactile push buttons. Okay, so audio here will tell, okay, green, walk. Then when they hear it, then they would be able to cross the road. Okay. Audio tactile is because it's a combination audio, and then you also need to put in tactile for visually impaired ones, because they not only listen, but when they are walking with their guide stick, they would need to feel on the ground. They would need to feel on the ground. Where are the directions? Are there any hazards in front? Okay, so that's where the tactile ground surface indicators come in. Yeah, so we'll discuss this towards the end of the lecture. We'll need to have color contrast as well, because like I said, visually impaired doesn't mean they are totally blind. Sometimes there could be slight impairment in their vision. They could still see some brightness, but not totally blind. Okay, so we need to have a bit of color contrast. Okay, and for people with mobility issue, we need to provide, say for example, curb ramps, ramps to underpasses, overpasses, footpath smoothing, and space for maneuver of wheelchairs. So these are things that we need to consider for mobility impaired person. Okay, sometimes we take it for granted. It's just one step, so we just step up, no issue. But then even if it is just one simple step, sometimes you see at the lobby you may have one step. So those kind of design is not very friendly user friendly for people with mobility disability. Yeah. Okay, so then it goes back to this Disability Discrimination Act of 1992. Generally, that law removes discrimination, and it says that all people have rights to access to premises, goods, and services. Okay, to all kinds of services and to all kinds of premises. All right. So we for this unit, we are just looking at the access to premises, in terms of the footpath, in terms of transport, of moving them, of moving people. Okay. Why do we have this DDA? Now, in in the past decades or so, we have a lot of improvement in our technologies in medical science. And recently, if you have seen, or rather, recently we know that with the COVID-19 vaccine has been produced in such a rapid speed. So all these are medical advancements, all right? And these have saved or extended human life. And so it is also time for our design to catch up. Okay, so it doesn't mean that they are, when they cannot walk around, they cannot contribute to society or they cannot access to the society. All right, so it's time for our design to catch up as well. Okay. By the way, what's our human life expectancy? Any one of you can give a guess? 60? Any other number? 100, 80, 70, 80, 80, somewhere around there. The last I checked, lifespan is about 75, 76. For women, is about 76, I think. For men, slightly shorter. Sorry to say, but that is general again. Okay. So if a person takes care of its health, of his or her health, then generally we see that the lifespan is longer. So, and therefore, time for our design to catch up. Okay. So then the objective of DDA is that it eliminates as far as possible any discrimination. So it eliminates discrimination on the grounds of disability in a range of areas, including access to premises. So for our topic, for our discussion, we are just looking at access to premises. And we ensure, or rather, the Act ensures that as far as possible, people with disabilities have the same rights to equality, okay, before the law as the rest of the community. So same rights to equality as in they can they get a job, they can get a job even if they are disabled. They can get access to education even if they are disabled. All right, so same rights for everyone. All right, and the Act also promotes an acceptance of the principle that people with disabilities have the same fundamental rights as the rest of the community. So the Act actually helped to ensure, for the second point, it's to ensure that those who are disabled will have the same right. Okay, so the second point here applies to those who are disabled. The third point is for the rest of us who are good and healthy, to accept that people with disabilities should have the same fundamental rights. Okay. So then our design has to catch up, and to provide for this, let me go back. To provide access to premises, we have to design for the pathway, the footpath, so that they can access the premises. Okay, so that design should be in accordance to Australian Standard 1428. So we will only discuss part 1 and part 4. Part 1 is the general requirements for access to new building work, okay, any new building. And part 4, tactile ground surface indicators for orientation of people with vision impairment. Yep, so we'll look at these two parts. Just before that, okay, if we look at this part 1, it is for new building work. why we only concentrate on new building. We know that some buildings are built in 1940s, some buildings are century old, some buildings are relatively new, but they put a threshold line to it. New building at least must comply to this Australian standard 1428. Okay, must provide access for people with disabilities. All right. So if for all building, what happened? Let's say the hotel was built way long. The hotel has been in operation 50 years and is still in operation today. But back in 50 years ago, people did not talk about having to have ramp access. So what happened? Now, under the law, under the Australian law, it is stated that if, let's say, let me check, they've included this in. No. Under the Australian law, they say that for all building, OLD, OLD, not ALL, for all building that was constructed before all this act came out, if the building owner is able to provide the ramp access without any undue hardships, without suffering bankruptcy, for example, because I need to construct a ramp, I need to spend money. So if, let's say, I can afford that amount without causing myself to starve myself, to go bankrupt, or things like that, without any adverse, too much difficulty to me, then I should provide the ramp. Okay, or it is recommended that I provide the ramp as a building owner. But if it costs me to suffer undue hardships, then we can forget about providing the ramp. Yeah, so that's what is stated for all buildings. Okay. Yeah. So first off, under the design, is a walkway design. Walkway design in terms of circulation space. So access ways, walkways, ramps, and landing shall have an unobstructed width of not less than 1000 mm, 1 meter, and unobstructed vertical clearance of not less than 2000 mm, 2 meter. Okay, so vertical clearance from floor to ceiling, it is, or rather floor to soffit, it is 2 meter, and width wise, it's 1 meter. And gradient and crossfall not exceeding 1 in 40. Okay, so this is stated. So yeah, so minimum width is 1000 if we are just considering for one person to walk. But if you are considering for wheelchair users, then it is 1002 mm. All right. And for different scenario, if one wheelchair user and another user with a stroller, then 1005. If two wheelchair users, we are considering 1008. So the walkway design, a walkway shall be provided with landings at intervals of, if the gradient is 1 to 33, not more than 25 meter. Okay, so what this means is, if you have a gradient, this is 1 in 33. So this distance, this horizontal distance, not more than 25 meter. Okay, so if the gradient gets steeper, 1 to 33, and then it gets steeper all the way to 1 to 20, then we are looking at distance of not more than 15 meter. Okay, so why is this so? Now, if you have a steep gradient and you imagine yourself in a wheelchair. So if you are here on a wheelchair, something like that. Okay, if you are here on a wheelchair and you are going to climb this walkway or this ramp on a gradient, yeah, your hands get very tired. So if it is very steep, you cannot have a very long distance. Otherwise, your hands get tired. Okay, so if you need to provide for longer distance, then you have to provide a flat landing. This is flat. Okay, so this is landing. Okay, and gradient of walkways between landings shall be constant. So from one landing to from one walkway to another, on this side, this should be also 1 in 33. So this one and this one should be constant. And if we are going for a ramp design, now the difference between a ramp design and a walkway design just now, walkway is longer, ramp is a very short distance. Okay, so if you look at ramp, longest is 1 in 15 meter. Okay, so ramp gradient is also steeper, 1 in 20, 1 in 14. Okay. But if your ramp is shorter than 1.1520 mm, then we can go for steeper gradient. We'll see that in a later part. Okay. Yep. So changes of direction, angle of approach is usually zero. Landings shall be provided at changes of direction. And for ramps, it shall be provided with handrails. Walkways, you don't need to have handrails. This is an example of the design. If we look at this is for a ramp, so you need to have a handrail, and this handrail is parallel to your to the ramp. Yeah? So if the ramp is on a slope, then the handrail has to be on a slope. If the ramp, or rather if the whole pathway on the landing part this is flat, then this is straight as well, horizontal. Okay. So then for this part, the ramp part, maximum gradient is 1 to 14. We see that it's between 1 to 14 to 1 to 20, with the distance varying between 9 to 15 meter. All right. Yeah, so any longer than that, you need to provide a landing to cut it off. And then this gradient should be the same as this gradient. So if you use 1 in 18, this side must also be 1 in 18. Okay. And we also see this. This is the tactile ground surface indicator. We'll see more in the next in the slides after this. And for crossfall, 1 in 40 max. And if the crossfall is sloping on one side only, it's also 1 in 40 max. Okay, if you have less than 1520 meter, just now we saw that, okay, 1520 meter, sorry, 1520 mm or 1.52 meter. If you have a very short distance, anything less than 1520 mm, you can have a gradient of up to 1 in 8. So this is very steep, but it is for a very short distance. And we typically use this for curb ramp, which is this. This is a curb ramp. This is on a curb, so this is the pedestrian crossing. And once you cross on this, this is a curb ramp. Okay. Yeah, maximum rise of 190 mm, aligned with crosswalk across the roadway, and should have smooth transition from ramp to roadway, no lip. Okay. Locate push button within reach. So push button is here. This one I think hidden from view. Right. So you have this is the curb ramp. Okay. Right. So another angle of the curb ramp. This part is the ramp, and this part just smooth it up. So if we look back here, Yeah, so this part, just smooth it up so that it's smooth. Okay. Yeah, earlier on I mentioned audio tactile push buttons. Push buttons. This one, no problem. But for those who are visually impaired, then we need to have short beeps to indicate when walk is displayed, or long beeps to indicate when don't walk is displayed. Some of these push buttons I've seen not in Australia, but in other countries, they have audio here. It's equipped with audio to inform, please walk. So you could also have that kind of audio system. All right, then other facilities that we provide are tactile ground surface indicators, TGSI in short. Okay, so these are to alert people who are blind or visually impaired to pending obstacles, to changes in direction, and to assure them that there is a continuous accessible path ahead of them. Okay, so it serves as three different purposes. And the use of TGSI must be consistent. Warning tiles installed 300 mm away from the hazard at least. Okay. Directional tiles installed in the direction of travel, and all tiles installed along imaginary guidance line. Okay. So if we look at this, yeah, so these are tactile ground surface indicators. I think we do see this around us, just that we may not be aware of it before this. So I hope that from now on, you are more aware of this kind of the function of these tactile ground surface indicators. Okay, so we see these two types. These are directional tiles. These are to assure the user that, okay, this is the direction to go. There is a continuous path ahead of them. For this round ones, this is to indicate hazard, whether that hazard is a real hazard, such as there's a road in front, there's an intersection in front, or the hazard could be to warn them that there is a change in direction. Okay, so either one of these two hazards. Right, so how do we install it? About 300 mm away from the hazard, we need to install this. Okay, warning indicators, about 300 mm away. All right, same with this ramp. This is for staircase. We need to install it prior to any hazard in front, prior to anything that changes in front of them. Okay, so we see this. Yeah, this one is reflective one. Okay, then we have here one before the staircase, and then for this one, we see that there are 4 pieces here, bigger area, and then followed by continuous, or rather directional tiles. So what this means is that it's still warning that there is a hazard, or in this case, the hazard is the change in direction. Okay. And we see how this is being arranged. This is for bus stops or curbside tram stops. Okay, so traffic flow is in this direction. This is a road. This is a road. All right. So this is the footpath, and we put up directional indicators here, and you have warning indicators. Okay, so another arrangement, we have this directional tile, and then hazard warning over here. Okay, so the hazard in this case is the crossing, so for them to be alert. Okay, and for tram stops, there's one here, and if you look at this whole stretch, these are directional path, and this is the hazard. Okay. So for bus stops, likewise as well, for bus stops. Okay. So you have this this is the bus area, bus bay, and then you have this hazard. Okay, this is the directional tactile indicator. All right, and this bus stop is in compliance or designed for mobility impaired and vision impaired. So this part is for vision impaired, and for mobility impaired, we need to have space, a spacious space for them to maneuver and get ready to go into the bus. So what they do is that if they are coming from this direction, then the wheelchair, they will go to this and reverse into this direction so that when the bus comes, they are ready to move into the bus. Okay, then we have this. This is to warn them of the change in direction. Right, so you can see, what you can see in the figure is that you have a lot of different directional tiles. So let's say if they are coming from this direction, once they sense that, okay, these are all round ones, once they sense that this is the hazard marker, hazard tiles, then they have to be careful what is in front of them. So when they prop further with their stick, then they will sense that these are directional tiles so that they will know this is to indicate change of direction. All right, so when we see all these tactile surface indicators, please don't park your bicycle on top of these hazards, on top of these tiles. Don't put something on these tiles. Respect these facilities because it is there for a purpose. Okay, so I hope that this topic alerts you more into the needs of your users, in particular, not just pedestrians, but also those who are mobile, visually impaired and those who have difficulty moving around. Okay, these are facilities meant for this group of users. So with that, I end my lecture here today. Thank you very much. Any question you have? Let me just scroll back on the... Now, why the stop sign has a cross mark there? Which one are you referring to? This is 448 before I ask the age. Which stop sign?
Hello, Dr. Elizabeth.
Hi.
I think it's the pedestrian one.
Let me try and find
Yeah.
this
Strike
one.
10 or strike 17 or so. Yeah, this one also okay. Yeah. I wonder why there is a sign S and then has a, how to say, the cross there. Slash. What
This one, is it?
yeah.
This one is to indicate crossing. S, I'm not very sure.
Oh, okay.
These are signs specifically for Australia.
Oh, yeah, no, I never.
Yeah, we don't see it here.
Yeah.
Definitely.
Okay.
Never did the meaning of tile pattern. The hazard tile put so close to the staircase though. Why the stop sign is across the like 10? Okay. Meaning, oh, no standing. Okay. Shun Wei, thanks. Okay, yep. No other question. Any other Any other thing that you want to raise up before we end the session? Good one, Shen Wei. Thanks for clarifying that. Okay, so I think if no further question, then we end it a bit earlier. I'll end the recording. I'll hang around if there is any other questions that you want to clarify. Okay, either with this lecture or with regards to your assignment. All right, so yeah, that's all for today. Thank you and bye-bye.